Take the third unit, magnetostatics. So what is called as the electric field? If we have a conductor and we place any external voltage source, due to that your conductor will be experiencing some field, we call it as electric field. So for a magnetic field we have to consider a bar magnet. So in a magnet we will be having north pole and south pole. So between north and south there will be a force of attraction. So it is usually north to south out of your conductor, out of your magnet. Inside the magnet south to north. So it forms a closed loop. So that imaginary lines we call it as magnetic lines of force or magnetic flux density. Now take down magnetic, study of magnetic field, study of study of magnetic field due to the current flow through a conductor, we call it as magnetostatics. Magnetostatics. Next, take it as magnetic flux line. Magnetic flux lines. Magnetic flux lines. The imaginary line around the magnet. The imaginary line around the magnet is called magnetic lines of force. Imaginary line around the magnet, we call it as magnetic lines of force. Imaginary line around the magnet is called as magnetic lines of force or flux lines. Next term, magnetic flux. The total number of magnetic lines of force is called magnetic flux. The total number of magnetic lines of force is called magnetic flux, denoted by phi. Next one, take as magnetic flux density. Magnetic flux density, capital letter B. Capital letter B. Definition: the total magnetic lines of force. The total magnetic lines of force crossing a unit area. The total magnetic lines of force crossing a unit area in a plane at right angle to the direction of flux. Full stop. Unit is Tesla or Weber per meter square. Weber per meter square. Next term, magnetic field intensity. Magnetic field intensity H. Newton per meter. Newton per meter. Next, take as relation between B and H. Relation between B and H. Similar to electric field. So in electric field, D and D को E को घुमा. Relation between D and E is epsilon E. Epsilon is called as epsilon is equal to epsilon naught, epsilon R. What is epsilon naught? Permittivity. It is usually 8.854 into 10 power minus 12. Similar, epsilon R value 1. Relative permittivity. Similarly, here between B and H, B is usually mu times of H. So here mu stands for permeability. Mu stands for permeability. Mu is generally represented as mu naught, mu r. Similarly, here mu naught is 4 pi into 10 power minus 7 and mu r is 1. So relation between B and H is B is equal to mu times of H. Mu stands for permeability. Mu is also equal to mu naught mu r. पहला R कर दो, it relates your relative value. So 1. Next topic taken as Lorentz force equation. Lorentz force equation. Important question. Lorentz force equation. So Lorentz force equation means it combines the force equation of electric field and magnetic field. So what is the force equation for electric field? Relation between force and electric field. So Lorentz force equation means we are going to write force equation for magnetic field as well as electric field. We are going to combine electric and magnetic field force equation. So force will be equal to, total force will be equal to sum of electric field plus sum of magnetic field. So what is electric field force equation? Second unit start करो. Started with Coulomb's law. What is Coulomb's law? F will be equal to Q1 Q2 divided by 4 by epsilon naught r square. So yeah, E is equal to F by Q. F by Q is E. F will be equal to dq. So for electric field, force equation is E into Q. Correct? Coulomb's law, F will be equal to Q1 Q2 divided by 4 pi epsilon naught r square. Force per charge will be equal to Q divided by 4 pi epsilon naught r square. So this force per charge we call it as electric field. So from this equation, F will be equal to E times of Q. E times of Q. So this is your force equation for electric field. Similarly, here also we have to write for magnetic field. So for magnetic field, again you will be having a charge into velocity cross magnetic flux density. For magnetic field, we will be replacing D by V. So instead of electric field, we are writing in terms of magnetic field along with V. V stands for velocity. So here this B cross B indicates it is a vector field. Okay, so the component is vector. So what is the difference between a vector and a scalar? Scalar means it will be having only the magnitude. Vector means it will be having magnitude as well as direction. So here in magnetic field the force will be depending upon the direction, whereas in electric field you will not be having any direction. Only magnitude will be considered. So the difference between force in electric field and magnetic field is, in electric field your force will be representing only the magnitude, not the direction. So it is a scalar product. Whereas in magnetic field your force equation or any other parameter will be depending upon its directions as well as magnitude. So it will be represented in terms of vector. So how to convert this vector into a scalar? First unit. So if this is your B cross B vector. So this is in vector form. Convert this into a scalar. In converting into scalar, magnitude of B into sin theta. So whenever your theta value ranges as 90 degree, sin 90 value will be 1. So it is maximum. Sin 90 is usually 1. So we can write B. B cross B will be represented as B into B. Sin theta value is 1. This is in terms of scalar. So here this cross indicates it is a cross product. So whenever you have a cross product, it represents your vector term. Okay, so Lorentz force equation means it will be combining your electric force as well as magnetic force. The difference between electric and magnetic forces, in electric force you will be considering only scalar quantity, not the direction. Only magnitude will be considered. In magnetic field, it will be considering both your direction and magnitude. Therefore, it should be represented in terms of vector terms or vector quantity. So to represent a vector quantity, we have to introduce a cross product. So cross product போடும்போது we have to consider the direction என்ன இருக்கும். அந்த சார்ஜ் எவ்வளவு ஸ்பீட்ல மூவ் ஆகுதுங்கிறதையும் சேர்த்து கன்சிடர் பண்ணணுமா. So when you consider that, you will be having a velocity. Velocity means it relates to your speed equation. So அதனால டைரக்ட்டா E க்கு பதிலா நம்ம என்ன எழுதிப்போம், in terms of B cross B ன்னு எழுதிப்போம். சரியா? So what will be your total force now? F will be equal to
E plus
Q E plus Q times of B cross B vector. So this is your Lorentz force equation. Therefore, your force can be represented as 2 times of E plus velocity into magnetic field. Q